Hello. Good morning, everyone. It's focused. Cool. Wait a few minutes for everyone to join up. Wow, pretty crazy stuff happening in the world. Or in this country, I should say. What's poppin'? I woke up a little late. Do you guys ever have it where it's like you are having a hard time sleeping and then it gets to like 10 minutes before your alarm is supposed to go off and then you fall into like an incredibly deep sleep? So that's what happened to me this morning. I was, I woke up at like 4 o'clock and I was just tossing and turning. And then when it got to like 6:20, my alarm goes off at 6:30. So it got to 6:20 and then I just immediately fell into a deep sleep. Wait one more minute. Okay, cool. So let me pull up my notes here for today. Good morning, class. So today we're going to be finishing up wireless networks. Okay. And after that we'll be I'm going to explain your programming assignment for this week, and then I'll also be introducing your final. So for your final exam, it's to write the first portion of your internal assessment. And so, it's not really designed, it's to be, not really designed to be an exam that's taken in a set amount of time because you're producing a paper. So I want to get that to you as soon as possible so you can get started on it. All right. So let's go ahead and talk about a couple of wireless things. This should be pretty quick. So I'm using my notes here. I want to talk about a couple of different wireless networks that have been used in the past. So there's 3G, 4G, and 5G. Okay. So these are third generation, fourth generation, fifth generation wireless networks that are used for mobile applications. Okay, so cell phones. So these all have different speeds. Okay. And that speed depends on whether you are moving or stationary. So they sort of have different rated speeds. So for 3G, in order to be counted as 3G technology, the network has to have download speeds of 200 kilobits per second. So kilo means 1,000 or 10 to the third. Okay, so that was 3G. I can remember when I was in college, 3G was the technology. Okay. When I was in college, I had a flip phone, and the original cell phones were those Razors, Razor flip phones, where to text people you had to press one like 3 times to cycle through all the letters to get to the one that you wanted. And then I got a flip phone with a full keyboard, and man, you could text fast on that thing with a full like mechanical keyboard. I have a hard time with the touchscreen keyboards like on an iPhone. I just can't. I'm just not very accurate. But with a actual where I can feel the keys with my thumb, I could text fast. Can't do that anymore. All right, 4G is a lot faster than 3G. 4G, if you are moving, you can download at 100 megabits per second. So megabits, mega means a million. So that's 10 to the 6th. So we go from kilo to mega. So that means 4G is like 500 times faster than 3G. That's a lot faster. If you're stationary, then you can actually get download speeds of 1 gigabit per second. All right. So giga means a billion. So, yeah, 4G is significantly faster than 3G. From what I could see, 5G is not really too much faster than 4G. 5G is something like 10 gigabits per second, according to my research. So it's not like 1,000 times faster like 4G is. All right. So these are some networks that were used for mobile phones. Okay. There's also I had never heard of this network, but apparently IB wants you to know about it. It's called the WiMAX network. And the WiMAX network is supposed to be, it's like an ISP. So, you think about, Spectrum or Verizon or whatever you have. It's wired internet, right? There's a wire that goes into your house, and then maybe you have a wireless network hooked up to that. So that's your ISP. So the ISP is a wired network, and then on your end, you can transform that the front end of that into into something wireless. But WiMAX is an internet service provider, but it's completely wireless. Okay, so it would be like Spectrum just has, so it's very similar to mobile technology, but it's geared towards not providing cell phone communications, but just regular internet. It's inexpensive, and it's this is a good option for rural / isolated areas. So if you want to bring I don't know, internet to some village in the middle of nowhere with very little infrastructure, then WiMAX is the way to go. There also exist things called sensor networks. Okay, and so these, there's a really good question: is WiMAX more or less secure than traditional Wi-Fi? I'm going to guess that it's equivalent, but I don't know for sure. I had never heard of WiMAX until I read the IB Computer Science textbook. So, has anyone heard of WiMAX before? Type it in the chat if you had heard of WiMAX before I discussed it today. Sensor networks are used to do things like monitor weather, like temperature distributions and things like that around the globe. So you have a network of sensors that are communicating with each other wirelessly, so we can figure out what's going on with the air pressure, what's going on with temperature. I could imagine like seismic sensor networks, okay? So these have a lot of science uses. Okay? So these are some wireless networks that you are supposed to know about. Okay, so now we're going to talk about network security. So, what are some different methods that you can secure a wireless network? So, wireless network security. And it has a number of really obvious suggestions. So one, of course, is use a password on your device, and also use a password to access the network. All right. So, hey, did anyone make a bug net? Did anyone make BugNet 5 or BugNet 4? You can also change the password for your network. All right. You want to have antivirus software on your computer. You want to have a firewall. So a firewall is basically going to completely block traffic that's coming from certain locations. Okay. You want to, I didn't know this, but apparently you can enable and or disable broadcast of your Wi-Fi name. So for example, if you are within the radius of the bug net, then if you go on your phone and you pull up wireless networks near me, it's going to come up. But you can turn that feature off so that the only way someone can access the network is if they already know the network's name. Okay. Apparently this method can be, there are special devices that will detect all networks, whether they're broadcasting or not. But it's kind of an easy method of security that you can do. So I don't know if you're worried about your neighbor accessing your Wi-Fi. You can turn on and off enable and disable Wi-Fi. So, if you are, you know, if you're worried that something bad is accessing your network via Wi-Fi, you just turn off the Wi-Fi period and only go with wired network for that time. You can allow access by MAC address. So MAC address. So your computer has a MAC address, and so basically I would go on to that router page that I showed you last time, and I would type in your MAC address for your device, okay, and then I would allow that MAC address or not allow that MAC address. Okay, so you're adding it's like the administrator of the network is allowing each device individually. Okay, so the only way you can get access if you are on that list. And then the last one method is the one that I want to talk about the most today, which is encryption. Okay, so let's talk about encryption, and that's the subject of today's programming assignment. Okay. So encryption is going to take a message. Okay. So maybe the message is hello. All right. And it's going to change it into what looks like gibberish. Okay. So it's going to change that into gibberish. So maybe maybe this message, and so usually the encrypted message is the same number of characters as the original message, but it's just gibberish. Maybe it's like 1F05G. I don't know. So that's what the message would become. All right. And then you also, the encrypted message is called the cipher text. Cipher text. All right. And then you also produce what is called the key, and the key could have different lengths. Okay. But generally speaking, you want the key to be large, and I'll explain why in a second. Maybe the key is 2A. I don't know. So the key is a string, and the ciphertext is a string. Okay. And then you have decryption. All right. Where decryption takes in the ciphertext and the key and mixes them together, okay, and it produces the original message. Okay. Now, anyone can see the ciphertext. So the whole idea is that it doesn't matter if you get a hold of the ciphertext because you don't know what that message corresponds to. All right. Anyone can see the ciphertext, but they can't read the message. without knowing the key. And so what you have is you can have what's called a brute force attack. Okay, where basically what a brute force attack is it's like typing in all possible passwords for a phone and trying to unlock it. Okay, so you basically try keys randomly until you get a message that makes sense. Okay, and so obviously the longer the length of the key, all right, the more time it's going to take to cycle through all the possible keys. Okay, so what they do is to protect an encrypted message from a brute force attack, what they do is they make the key long, and that makes it harder to cycle through all the possible keys. So I believe right now we are sort of in the era of 256-bit keys. Okay, and what that means is the number of possible keys is a sequence of ones and zeros that's 256 long. And it's something like more than the number of atoms in the known universe, in the visible universe. Okay, so there's so many possible keys that it's, in order to find the right key, you would have to do this brute force attack and run it for decades, millennia, in order to get, so basically by the time that you cracked the key, the message is useless anyways. Okay, so that's how we achieve security. There's a couple of types of encryption. Okay, and there's something called symmetric key encryption. Okay. All right. And symmetric key encryption is not as good as the. So basically, the two parties both have a key. All right. Or they both have the key. All right. And the same key is used to encrypt and decrypt. All right. So the disadvantage of symmetric key encryption is that you need to get the other person the key in a secure fashion. All right. And furthermore, you have to trust the other person to keep the key secret. Otherwise, anyone's going to be able to read the message. So symmetric key encryption is not so great for that reason. Then, fairly recently, some mathematics was, or I guess the mathematics wasn't discovered, but people realized how this mathematics could be used in encryption. Some new technology was developed called public key encryption. Um, and with public key encryption, you have two keys. All right? You have a public key. All right? And then you have a private key. And the public key is used to encrypt the message. All right? And then the private key is used to decrypt the message. So why is that much, much better? So what would happen, what this does is you don't have to rely on the person who's sending you a message to keep the key safe. All right? So here's what you do. Let's say I want to receive a message from you. Okay? I give you a public key that corresponds to my private key. So only I have the private key. Okay? I give you the public key. You use the public key to encrypt the message. So now the message is all scrambled up. You send me the message. You can't use the public key to decrypt the message. You can only use it to encrypt the message. Okay? So no one else can read the message. All right? And it doesn't matter if that person then loses the public key later on or whatever happens to the public key. Okay? I receive the message and only I can read it because only I have the private key. So it's a more self-reliant way. So this is why public key encryption is really, really powerful and is used in like banking transactions and things like that. Okay, you don't have to rely on someone else to keep the key safe. Now, you might have heard of quantum computers before. Quantum computers would be able to crack public key encryption in a reasonable amount of time. So a quantum computer can do a brute force attack on public key encryption and expose a vulnerability there. So we might have to develop new encryption algorithms after quantum computers become prevalent. Okay, so I want to teach you a really simple method of encryption. It's a symmetric key encryption. All right, and it's called a shift cipher. All right, you've probably heard of this before, or once I explain what it is, I think you will know it. That's a good question. I'm not sure of any quantum computer encryption algorithms. One of the things about quantum computers is quantum computers, if you think about a normal computer, a bit is either 1 or 0. But in a quantum computer, a bit is a superposition of 1 or 0. So you might have heard of Schrodinger's cat, where the cat is alive and dead simultaneously. It's in a superposition state of being alive and being dead. In quantum computers, you have bits that are a superposition of being 1 and 0. So they're like partway in between the two. And you can have a lot of different superpositions. You can have a superposition of 1 and 0 that's mostly 1. So that, when you measure it, you get 1 most of the time, but not always. The quantum version of bit is called a qubit, a quantum bit. And so, yeah, they're a completely different beast. I haven't read a ton about quantum computing. I mean, I understand quantum mechanics, but I haven't read up much on quantum computing. Maybe I should. Okay, so let me tell you about a shift cipher. This is a super basic method of encryption. So let's say my message is hello, all right? And we won't worry about uppercase, lowercase, so we'll just say it's hello. And so let's say the key is um, going to be a number between 0 and 25. All right. Actually, I don't want this to be my message, just because I want to illustrate something. Let's say that the message is zebra. Okay. So let's say that the key is let's say 4. All right. So what we're going to do is we're going to shift each letter by 4 through the alphabet. And I chose a word that starts with Z, because what if you have Z? Well, you do it cyclically. So if I shift Z by 1, then Z becomes A. All right? So the ciphertext is going to shift each letter by 4. Okay? So if I shift Z by 4, I get Z goes to A, B, C, D. Okay? So Z becomes D. E becomes F, G, H, I. B, C, D, E, F. R, S, T, U, V. A, B, C, D, E. So I shifted all of the letters by 4. Okay, so that's called a shift cipher. It's very simple, and so that would be the humans can actually crack a shift cipher really easily. First of all, because there's only 26 possible keys. So if you wanted to brute force attack this message, if you wanted to brute force attack that message, then you would get, it wouldn't take that much time. A computer could do it really easily. You just try all the different keys, and one of the keys is going to make sense. The message is going to make sense. Everything else will still be gibberish. The other thing that the shift cipher does is it doesn't change the letter frequencies. So the English language, for example, certain letters appear more than other letters. There's a statistical distribution of letters. Okay. And so if you have a long message that's encrypted with a shift cipher, you can say, oh, this letter is appearing 10% of the time, and in the English language, the letter A is 10% of all letters used, or something like that. And so you can sort of guess what the key is going to be. All right. For your assignment, okay, you are going to encrypt using what is called a OneTime Pad. And this is an ultra secure symmetric key encryption. There's no way to crack it because it completely randomizes the message. The only way you can crack it is if you have the key. All right. And basically what it is a shift cipher. But each letter is shifted by a different amount. Okay. So maybe our message is zebra. Okay, so the message is zebra, and we're going to encrypt it using the key, let's say 10652. So Z is going to get shifted by 1. So the ciphertext is going to be this. Z is going to get shifted by 1. So Z will get shifted to A. All right? The second letter is going to get shifted by 0. So it stays as E. B is going to get shifted by 6. C, D, E, F, G, H. R is going to get shifted by 5. S, T, U, V, W. And then A is going to get shifted by 2, B, C. All right? So that is the ciphertext. All right? And then, you know, to decrypt, obviously, you use the key and you reverse shift it. But what this does is it completely destroys the frequency of each letter, right? So you can't guess what the key is based on that. An important point with the OneTime Pad is this sequence of numbers must be random. Okay, it must be random. Because if it is not random, someone could take a bunch of messages that have been sent using OneTime Pad, and you could actually figure out what the distribution of randomness is, which makes it vulnerable to attack. Okay, I once read this book on cryptography, and there are a lot of statistical based methods of attack that are really crazy, where it's like you take a bunch of messages and you statistically analyze all of them, and you use that to figure out how the message is being encrypted. There are even attacks where they can like listen to keys being typed and use that to determine what the what the password is or what the key is. You can figure out how long is the key approximately. You can figure out what is the key from, you could even monitor the electrical use that the computer is using while it's encrypting the message. There are attacks based on that. So there's a lot of really sophisticated technology that goes into this stuff. It's pretty cool. All right, so I will see you in the Zoom room where I will talk to you about your final. Bye for now.